All right, welcome back. We are in Unit 2, Lesson 12. We're getting towards the end of this unit. We are using graphs to compare relationships. So we've done proportional relationships in tables and equations, and we've seen them on graphs. And today we're going to use what we know about them on graphs to interpret maybe what that data means and draw some conclusions. We're going to start out with a number talk. So what I'd like you to do is stop the video and go ahead and solve those mentally, and then come back and see how your thinking compares to my thinking, remembering that my thinking is not the only way of doing these problems mentally. As long as you get the same answer and it's mathematically sound thinking, that is fine. All right, so when I look at this problem, 2/3 times 1/2, I think in my head, I think 1/2 of 2/3. Well, if I have 2/3, half of them would be 1/3. All right, this one, I'm going to do the same kind of thought process. Excuse me. I'm going to think 1/4 of 4/3. Well, if I have 4/3, 1/4 of them would be 1/3 again. All right, 4 divided by 1/5. Well, that is asking us how many 1/5ths are there in 4. Well, if I think about it, there are 5 1/5ths in 1. And then I have 4, so I'm going to take 5 times 4, and that's going to give me 20. All right, this one, I thought of it as, well, we have 6 here, and we have halves here. So I thought of changing the 1/2 to 3/6. And then I asked myself, 3/6, how many 3/6 are there in 9/6? So if I have 9/6, so how many 3/6 are in 9/6? Well, if I take 9/6 and break it up into 3/6, that makes 6/6, and another 3/6 makes 9/6. So how many of them were there? There were 3. So that was my thought process. Maybe you thought of it as a multiplication problem, multiplying by the reciprocal. That's fine. All right, so we're going to do race to the bumper cars. So we are building off of what we did previously with Tyler, going from the ticket booth to the bumper cars. And now it looks like 3 of his friends have joined him, Diego, Lynn, and Mai. So let's see what happens. So it's telling us to use each description to complete the table representing the person's journey. So let's start with Diego. Diego left the ticket booth at the same time as Tyler. Diego jogged ahead at a steady pace and reached the bumper cars in 30 seconds. So what's important here is it's a steady pace, so that means it's proportional. So at 30 seconds, he got to the bumper cars. Well, where was he at 15 seconds? Well, we can take and look, we can look at it this way and say, well, that's half, so what's half of that? 25. The other thing we can do is we can figure out his rate. So if I take 50 divided by 30 by doing y over x, that gives me 5/3. So if I multiply this times 5/3, that's going to give me the 25. At 0 seconds, where was he? Oh, he was still at the ticket booth. At 1 second, where was he? Well, if this is our COP, our constant, I'm going to multiply this times our constant. So he was at 5/3 meters, which equals 1 2/3 meters. All right, let's look at Lynn. Lynn left the ticket booth at the same time as Tyler. She ran again at a steady pace, that's important, and arrived in 20 seconds. So the ticket booth is 50 meters away, and she got there at 20 seconds. So let's do the same thing. Let's find her rate, her y over x. That would be 5/2. So we know this is going to be 5/2. which is 2.5. All right, at 0, she was at 0. So now what are we going to do with this? Well, at 25 meters, how long did it take her to go 25 meters? Well, half of this. So what's half of this? 10. Now we could have also divided it by 5 halves. All right. Now we have Mai. Hers is a little bit different. She left the booth 10 seconds after Tyler. Her steady jog enabled her to catch up with Tyler just as he arrived at the bumper cars. So when she was jogging at a steady rate. But looking right here, this is saying at 40 seconds she got to the bumper cars. But what, did she run for the whole 40 seconds? No, she actually ran for only 30 seconds because she hung around at the ticket booth for another 10 seconds. So her rate is going to be 50 over 30, which equals 5/3. So we're going to put that right here. Whoops, let's change that. Where was she at 1 second? We need to think about what this means. Where was she at 1 second? She was still at the ticket booth. Okay. At 0 seconds, she was 0 distance. Okay, now 25. If I divide this by 5/3, I get 10. But at 10 seconds, she wasn't there. 10 seconds, she was just leaving. So we have to add that 10 seconds that she hung around. So she was really at 25. Okay? So this would have been, let's see, 5/3, 25 divided by 5/3 would be 15, and then we add that 10 onto it. All right? Okay. So now they're asking us to use a different color for each person and draw a graph of all 4 people's journey, including Tyler. And if we go back and we remember, Tyler ran or jogged. It took him 40 seconds to get to the bumper cars, which were 50 meters away. So let's start with Tyler. Something stuck in my throat. Let's start with Tyler. So we know he started out at the ticket booth, and then it took him 40 seconds. So here's our seconds. I'm going to find 40 to go 50. So that would be right here. I'm going to take my straight edge, draw my line, and that's Tyler. Okay. All right, now let's do Diego. We'll do Diego in, let's do Diego in blue. Okay. Let's see, Diego, it took him 30 seconds to get to that same 50. So he's to the same 50. It took him 30 seconds. So that's going to put him right here. So let me connect the dots. That would be Diego. All right. Then we have Lynn. She took 20 seconds to go that 50. So 20 seconds is right here, the same 50. So this is Lynn. All right, and then the last one we have is Mai. Now hers looks a little different because what did she do? She hung around during this time and didn't go anywhere. And then she took off at 10 seconds and she got there at the same time as Tyler. So that is going to be Mai. All right, so that's what your graph should look like. Now, which person is moving the most quickly? Well, let's look at it. Here is the bumper cars. Okay, this is the bumper cars. This is the time it took. So who got there first? Who got there in the least amount of time? Well, at 20 seconds, Lynn got there. Diego didn't get there till 30 seconds. And Mai and Tyler didn't get there till 40 seconds. So who got there first? Lynn got there first. How is that reflected in the graph? Well, she gets to 50 before anybody else, but hers is also a steeper graph. Okay, it looks steeper, and she gets to the bumper cars first. If you look at it, who's the first one that gets there? Well, she gets there at 20 seconds. So she gets to the bumper cars. Which is that 50 meters first. All right, now they want us to write an equation to represent each person's time. Well, let's look at it. Let's see. What else could we look at? Okay. All right, so Lynn, let's start with Tyler. Tyler takes 40 seconds to go 50. So that would be 4/5 is his rate. Am I correct? Let's make sure. This point right here is 40, 50. Well, so Tyler's y over x would be 5/4. Okay. We're going to skip Mai for right now. We're going to look at Diego. Diego's y over x. So this point right here for Diego is 30, 50. So his y over x is 5/3. Lynn, this point right here is 20, 50. So her y over x is 5/2. So if we call the time, the elapsed t, and this over here d, Tyler, his equation, so let's start with Tyler. His equation is going to be distance equals, what was his rate? 5/4, that's his k, t. So at 1 second, he was 1 1/4 meters away from the ticket booth. Let's try. And there we go. All right, then we've got Diego. So his distance is 5/3 or 1 2/3 t. Okay. Okay. Then we have Lynn. Hers is 5/2. So D equals 5/2 t. Now Mai's is going to be a little bit different. Let's look at Mai's. And I am just having technical difficulties here with these pencils. There we go. All right. So Mai, she is going to be, her distance, when she ran at a constant rate of 5/3. But her time is going to be t plus 10. Let me make sure I did that right. Don't want to tell you wrong. All right. Okay. So now let's move on to space rocks and the price of rope. So we have this graph, and let's notice some things. We have time down here and distance over here, and we don't have any numbers, but we know that this is time and this is distance. So the meteoroid Perseid 245 and the asteroid X travel through the solar system. The graph shows the distance each travel after a given point in time. Asteroid X is asteroid X, this one right here, traveling faster or slower than person 245. Explain how you know. All right, so we don't have any numbers to look at, but we can make some assumptions. What if we draw a line right here and we call this one, whatever time frame you want to do. If you want to do 1 hour, 1 minute, 1 second, 1 day, doesn't matter. And then this is distance going this way. All right, so who traveled? Asteroid X is right here. Here is how far. Let's see. Who traveled the furthest? Well, Asteroid X traveled this far, but Perseid 245 only traveled this far. So which one traveled further? Asteroid X. So he's going to be faster. And how do we know? Because his y coordinate is going to be greater, or his distance is further at that one whatever. All right? So the distance is greater than Perseid at any point in time. If I picked a different place, let's say I picked this point right here. Draw the line up here. Who's further? Well, this is the distance Perseid is, and this is the distance the asteroid X is. Which one is further? Asteroid X is further. All right, now we have a graph that shows the price P of different lengths L of 2 types of rope. Okay, once again, we're not given any scale or anything, but we are told that this is the length and this is the price. All right, we want to know, if you buy $1 of each kind of rope, which one will be longer? Now remember, this is money and this is length. Okay, so we're going to pick a point and we're going to call this $1. So we're going to go across here. Remember, this is length. Which one are we going to get more rope of? Well, here is the length of the nylon rope. Here is the length of the cotton rope. So which one are we going to get more of? We're going to get more of the nylon rope for $1, and that's because the length is greater than the cotton. Okay, at $1. All right, so I just drew in where I wanted $1 to be. It could be anywhere. It could be up here. Well, which one am I going to get the most of? I would continue this line right here. Which one am I going to get the most of? Nylon rope. I could have made one way down here. All right. So that's how you can interpret a graph that's not given any scale and being asked questions about it. All right, so for summary for this lesson, we can compare points that have the same value, x value, or the same y value. For example, the points 2, 12, right here, and 3, 12 tell us that at store B you get more pounds of berries for the same price, because this 12 is the cost. So $12, I get 3 pounds at store B. $12, I only get 2 pounds at store A. The other thing I could look at was 3, 12 and 3, 18. So when I buy 3 pounds, when I buy 3 pounds, I'm going to spend $12 here. When I have 3 pounds here, I'm going to spend $18 here. So I can look at it either when they're the same this way or the same this way. All right, the other thing I can look at is, what is the COP? Well, remember, the COP occurs when X is 1. So for store B, this is saying that 1 pound of blueberries costs $4, And at this store, 1 pound of blueberries costs $6. So it's obvious that store B is a better bargain. It's cheaper there. All right, so you can either look at it when the X is the same, or you can look at it when the Y is the same and then make your conclusions. All right, I hope you enjoyed this lesson, and I will see you on Zoom to do some practice problems.